Hello, welcome to data types and operators in Java. So you might have a question about whether data types are important. So data types are important for strongly typed language. And since Java is a strongly typed language, all operations are type checked by the compiler, which means illegal operations will not be compiled. So we have primitive data types in Java, and the reason why they are called primitive data types is because these types are not objects, but rather normal binary values. So you can see that um, Boolean, byte, char, double, float, int, long, short, they are primitive data types. And you can see for each type, there is a meaning next to it. So unlike primitive data types, other data types are uh, constructed from these primitive types. To go over integers more in detail, so we have mainly four integer types: byte, short, int, and long. They differ in width in bits and also the range of numbers they can represent. So byte, because it's 8 bits in size, you can only represent from negative 128 to 127. Short, because it's in 16 bits, it will be able to represent negative 32,768 to 32,767. And because int has 32 bits, it will be able to represent bigger numbers. Long, because long is 64 bits. You can see that long, any data that has long integer type can represent this large range of values. If you are from a different language background, where from such as C, C++, there uh, those languages have a way to represent unsigned integers. So this range will only be represented in positive values, but in Java, there is no unsigned integers. That's one thing to keep in mind. Floating point types, there are mainly two types. There's float that is 32 bits wide, and there's double that's 64 bits wide. Similar to integer, it will represent range from positive to negative floating values. And the thing you want to be aware is that there are two types of division. One is integer division and another is double division. So you can see from this example, we have this integer v that holds integer value 10. We have this variable x that holds floating value double, and that is 10.0. So if we divide integer by 4 and this double by 4, we would get a different value. So for this double, you will be able to get 2.5, and for integer one, because integer division works differently, you will only get 2, which means the floating point will get truncated. And for characters, Java uses Unicode. For those of you who are interested in Unicode or different types of encoding, I encourage you to look into this. And there's this Boolean type, which value can be either true or false. Here is a second program that demonstrates two integers. The first integer has 1,000, and then you can print the first integer is 1,000, and if you can store the second integer by dividing 5 by 5. So this basically demonstrates variable, and variable is a named memory location that can be assigned a value, and the value of variable can be changed. So all variables, as you can see in the example, must be declared before they are used. So the type of variable must be specified. When talking about variable, it is really important to understand scope and lifetime. So variables can be declared within any block. And when we talk about block, you can think of this bracket. So this block basically defines a scope. And what we mean by what does scope do? Scope basically determines objects' visibility and lifetime. So we have variable x that is declared within main, and we have y that is declared inside a block that has if. So we have this y, and after this scope is over, y is out of scope, so y won't exist. But x, because x lives within this main, start of main at the end of main, x should be visible inside the scope that is defined by if statement. Operators is basically a symbol that tells the compiler to perform a specific mathematical or logical manipulation. So for examples would be arithmetic operators, relational operators, logical operators, bitwise operators. So arithmetic operators, there are 7 notable ones. In addition to addition, subtraction, multiplication, division, there's modulus, increment, decrement. Modulus would probably be the least known one. So here is an example. So you can see that we have this program that demonstrates modulus operator. So we have I result, 10 divided by 3, I remainder, 10 modulus 3, and we have double result, 10.0 divided by 3.0, and double remainder 10.0 modulus 3.0. So modulus basically lets you know what the remainder value is. And we have relational operators, which is similar or almost same as other mainstream languages. So we have less than equal, greater than or equal to, not equal. And we have logical operators. So you can use and, or exclusive or, short circuit and not. I guess they are all interesting, but one of the most interesting one that I find most interesting are the short circuit or and short circuit and. So Java supplies a special short circuit version, these, so that you can produce more efficient code. So here's an example. So here we have this if condition here and here. They have short circuit and we only if these two conditions are met, we will print this statement: D is a vector of n, and here as well, D is a vector of n. And when the first condition is only after the first condition is met, the second condition will be evaluated. So in this example, because we set D to 0, we know that the first condition is not going to meet, so we are short-circuiting, so we're not doing the second operand. So whenever you have really expensive second operation, you can check the first condition and use short circuit and. Type conversion, this is something interesting for in Java. So there are two ways the Java does type conversion. One is automatic type conversion. So if you have compatible types, the conversion will be automatically done. And for other types that can be converted with automatic type conversion, you have to manually use typecasting so that compiler can convert one type into another. So here is a operator precedence. We have operators, and you may be wondering which operators are going to be executed first. So we have postfix increment and increment prefix. Postfix increment decrement will be done first, and then prefix increment decrement and unary operation typecasting, then multiplication, division, modulus, plus minus, so on. So just keep this in mind whenever you're not sure. And lastly, we're going to talk about keyboard input. So for all the example you've seen, we have been using system out print line, which gives output to console. And you can not only give output, but you can receive information from the user by using system.in.read. And there are a couple of methods that are useful if you want to read a specific value of a specific type from the user. That's everything for this lecture. Thank you.